Right, so today I'm talking about physics and oscillation graphs. Now there's a lot to cover in here, so that's why this one's kind of longer. So let's jump into it. First I want to take a look at what the graph even looks like. All of these graphs are going to look like some form of a sine wave. And so just this repetitive motion. So if I take a weight and I put it on a spring, it's going to bob up and down when I pull it out of equilibrium. So what is this point of equilibrium? Well, if I have a mass suspended on a spring, if I pull the mass down, then it's going to oscillate up. It's going to oscillate up and down. And if we took a pen and we held it with this and moved some paper along, kind of like for like an earthquake thing, then like a seismograph, then as we move the paper, we're going to notice this nice curve develop, and it's going to be this sine wave. So when we look at these waves, what are we looking at? And then we'll get into these graphs. So the height of a wave, or the distance from the equilibrium point to the max or minimum ending position, is called the amplitude of the wave. So just how high it is, or how extreme how far it goes when it comes from this equilibrium point of rest up and back, up and back. So if we were going by the lines of the paper, this would be like an amplitude of 1. So I'm going to put a positive amplitude and then a negative amplitude as well, because it goes up and then it goes down, up and down, up and down. The next thing to talk about is the period of the wave, or the oscillation. And so kind of the way I think about it is that it's when you get back to the same point in the oscillation. So I think you would want to go up and then, oh, I'm back where I'm at. But not really, because you haven't completed it, because you're going to go back down and then you're going to come back up. But once you get to this point, this piece of the wave and this piece of the wave look exactly the same. And so that's where you find your period. It's going to be a repeating section, where if I just looked at this piece of the wave, that doesn't match that piece of the wave. But this entire section of the wave, this period, which is one period, equals that. And so remember that t equals 1 over f. So our period is the inverse of our frequency. So if I have like concert A is at 440 hertz. So if we think about this wave, we flip it over, we find the period, we can draw this wave related to seconds because hertz is in seconds. So that's some stuff to know about graphs.